Hi, welcome back. Today we're going to do our pre-algebra lesson on the Pythagorean theorem. Let's go ahead and get started. The Pythagorean theorem is dealing with right triangles. So we're learning about the distance around a triangle using a special formula that a Greek philosopher created. And he was Pythagoras, and so that's why we call it the Pythagorean theorem. Now, a right triangle has two parts to it. Well, actually, three parts to it. And we're going to discuss all of those. Now, to be a right triangle, that means that it has 90-degree angle of it. The largest angle of our triangle is a 90-degree angle. And you will know that it's a right triangle because we use this little square in the corner between two edges to indicate that at that point it's a right angle. Okay? Now, on a right angle, or a right triangle, I'm sorry, you have the different sides to them. And your sides have different names. So you have two different sides. You have this side, which we call a leg, and we have the other side of the angle, of the right angle, which is also called a leg. And we could call this side side A and this side B. And really it doesn't matter which one is A or which one is B. They're easily interchangeable. The main idea is that we want to know that the legs are just the part of the right angle. Okay? Now, the line that is the longest part of our triangle, and it also happens to be directly opposite our angle, right here, our right angle, that is our longest line right here, and that side is called the hypotenuse. You may have heard of this before, but our hypotenuse, again, is the longest side of our triangle. And we want to give this a different name so we could easily write a formula. So we're going to go ahead and call it C. So there's our parts of our right triangle. Go ahead and pause the video and copy this into your flip notebook. Excellent. Well, now we want to talk about squares, and that seems kind of strange. Like, why are we talking about squares when we were just talking about a triangle? And I'll show you how it connects pretty soon. But do you remember how to get the area of a square? That's right. Area of a square, or any parallelogram, is length times width. Okay, so if we looked at these three triangles, actually they're all connected and will all be used in our triangle. So if we said that this is triangle A, and we said this is triangle B, and then we said this is triangle C, we kind of think about our triangle that we were just looking at. Our largest part was C, our longest line was the hypotenuse. And then we had two legs. We had leg A and we had leg B. Now, in this square right here, in square A, the area of it is, it's a 3 by 3 square, so that means it's 9. The area of square A is 9. And square B is a 4 by 4 square, so the area of square B is 16. And if we look at area, or to look at the area of square C, we see that it is a 5 by 5 triangle, and that makes 25. And if you looked at a connection, if you could make a connection between these three, we would see that A plus B, the area of A plus the area of B will equal the area of C, because 9 plus 16 equals 25. And if we took the square root of each of these, if we said, okay, well, what is the square root? The side of the square. So the square root of 9, the square root of 16, or the square root of 25, we would have a 3 here, and a 4 here, and a 9 here. And we know that 3 plus 4 plus 9 does not equal 25, but the squares of those numbers do. So that's interesting. Well, let's see how it connects. If we turn these triangles, if we turn the squares, manipulated the squares, we could see that we could have square A here, which again was 9, and we could have square B here, which again was 16, and here is square C, which was 25, And if you notice the way we've twisted and turned them, we've created, right in the center, a right triangle. How interesting. Now, and one of the sides of the square root of 9, which happens to be 3, is for this side or this leg, and the square root of square B, which is this side of our triangle, which is 4. There we go. And then it makes our longest line, which is line C, and that would be one side of our square, which is the square root of 25, and that's 5. And that's how we get this formula, a squared plus b squared equals c squared. And that is the formula for the Pythagorean theorem. That's our Pythagorean theorem formula that we will use for right triangles. Interesting. So once again, we're seeing that the squares that can go around a triangle, if we add them together, this square, a squared plus b squared, it equals c squared. Interesting. Pause the video and add this information into your flipbook as well. All right, so again, we know that the Pythagorean theorem is, we just said, was a squared plus b squared equals c squared. So we're saying whatever we put here, this is going to be a, whatever we square it, and whatever we put down here, b squared. And again, we could put this to be b squared if you wanted, and this to be a squared. It really doesn't matter. And it will equal this side. This side will always be, the longest side will always be c squared. So a squared plus b squared will equal our c squared. Let's do some practicing, okay? Here is our first example. So in your flipbook, you have a triangle with these numbers in it. And we're going to go ahead and apply our Pythagorean theorem. Again, a squared plus b squared equals c squared. So if we said 5 and we square it plus our, if this is a, then this is b, and plus 12 squared, it will equal c squared. So we're going to put that information into our formula, and then we're going to calculate it. So we have 25 plus 144, and it will equal c squared. So what do they equal when we put them together? 169 is equal to c squared. Well, the line is not itself 169 units. So because it's squared, we need to figure out what c is all by itself. So we're going to take the square root of that number, because this is c times c. So the square root of our number, and we're going to see that 13 is what c is equal to. So the part of the line, the hypotenuse, that would equal 13. Okay? Go ahead and add this information into your flipbook. Here is our next example. We have a square, and I wanted to show you that the triangle this time looks a little differently. So our legs are up here, and we know that they're the legs because here is our right angle, and our legs are always the two lines coming off of that right angle, and our hypotenuse is always the one that's opposite our right angle, and it's always the longest side, and that's our hypotenuse. So here we go. A squared plus b squared is equal to c squared. So it again doesn't matter which number you use for a or b. I'm going to use this for a, 3 squared, plus b squared, which is going to be 4 squared. And we have 9 plus 16. And if you remember from our squares earlier, what we're going to get, so this is going to be 25 is equal to c squared. Remember, this is c squared, which is c times c. We need to figure out what 1c is equal to. So we're going to take the square root of 25, and we will find that 5 is equal to c. Go ahead and add this information into your flipbook. All right. Well, here we have a different example, and this time, if you notice, we have our hypotenuse, and yet one of our legs is missing. We're still going to use the same formula, a squared plus b squared equals c squared. And we're going to go ahead and plug in our information, but this time we have to work a little bit backwards. So we don't know what A is, so that stays there. B is 32, so 32 squared. And C is 40 squared. So with your calculator, you're going to determine that 32 squared, so A squared, plus 1024 is equal to 1600. And we're going to solve for A, so we're going to subtract 1024 from both sides. And when we do that, we find that we get 576 is A squared. And to solve for A, again, because it's A times A, we need to do the square root of 576. And what we find is that the side that's missing, the length of that side, is actually 24. Go ahead and do this in your flipbook. Okay, we have our last example for the day. It's similar to the one we just did. Again, we are given the hypotenuse part, and we're given one of our legs, but one of the other legs is missing. So if we use our formula, a squared plus b squared equals c squared, we have a this time, which is 7 squared. We don't have b, so we'll keep that there. And c squared is 25, and we're going to square that number. So 49 plus b squared is equal to 25 squared is 625. We're going to subtract 49 from both sides so we can isolate our b squared. We're going to isolate it. And b squared is going to be equal to, on my calculator, 576. I think we just had that number. And the square root of that, yep, same as our last one, is 24. So again, we can find it when we know both of the legs. We can find it when we know the hypotenuse on one of the legs. We are just solving for the missing part. Again, put this in your flip book. So finally, for your homework tonight, I'm going to have you copy and complete these problems that are still in your flip book, and we'll talk about them tomorrow. Have a good evening.